Hello everyone, this is Nino, and in this video I'm going to show you two examples of an artificial intelligence which is operating by matching patterns. Both are written in BASIC and both operate on the input and output of numbers. I chose numbers as an interaction facility for the following reason. A number can represent anything. It can represent text, it can represent audio, it can represent images, anything you like. So that I show you that the principles which I am describing about pattern interaction are generally applicable and actually independent of text, which is the subject matter of my usual experiments. The idea will be this. In each case, I will input a number into the system and I will receive from the system a number as a reply. The system will in each case reason based on the current situation. The current situation will be more than the number which I tell the system. It will be a set of numbers describing the last several interactions. The system will compare this most recent history of interaction to the patterns known to it in its knowledge base once it has determined the greatest similarity between the present situation and a known experience. It will output the reply belonging to that experience, and during the interaction the system will update its known patterns by means of those patterns which I enter into it. In other words, the system will be learning during the interaction. After this general description, let us plunge into the matter with the first system. It now asks me to input a number. I am free here to choose anything. Let's choose 13 for luck. Now you see, after I entered into the system 13, 3 more lines were output. Of these 3 lines, the last line is the system's reply to me. Those 2 lines in the middle serve to elucidate the system's manner of thinking, if I may call it that way. This topmost line of the 2 middle lines contains the most recent history. These numbers signify what the system has observed most recently. They are 4, but they could have been any number. They could have been 10, they could have been 7. Really, you pick what the system sees as a most recent situation, and that I picked 4 as a design decision. Noteworthy are 2 numbers here. First, notice that 32,767 is my filling material a priori. As long as the system hasn't learned anything, all its vectors, everything it uses to store information, is filled with this number. And in the most recent history, which is the current situation, notice that the last number has been updated as 13, which is the number I have input. As the system knows nothing yet, then it compares the most recent experience to its known patterns and arrives at the conclusion of, hey, that looks like the default pattern I know, which is 32,000, 32,000, 32,000, and again 32,000. And as fanciless as its reply of 32,000. This is going to change with the further interaction as it learns further patterns. Let's now input 34. Now notice that the most recent history, which is used for pattern matching, has been updated. It now contains 34 because this is what I input, It contains 32,767, which is what the system replied to me before that. And it contains 13, which is what I said first. And this other 32,000 is the preset number, basically, as long as the system did not yet interact. I shall now input a few further numbers, let's say 45. Now the system is looking at this history or situation. Notice that it no longer contains the 13. Now this is just composed of the last two interactions, and the 13 is already too far away to be looked at during pattern matching. However, it has become part of the system's knowledge base. And now the most fitting pattern has been judged to be this, and the system issues this as a reply. Alright, let's continue and you will see the complexity grow. I shall say 42. It is now updating again the history, matching and replying. I shall say 43. Now notice something interesting. It has removed its pattern matching from the default pattern. It is now giving also a different reply to me. When I say 43, it is saying 34. And it is deeming that these two patterns are similar. It is saying if this is your most recent history in the first line, then I know about that pattern in the second line, and gives me a reply. I shall next say 2. It says 45. If I say 467, it is saying 42. If I say 908, it is saying 43. If I say 19, it is saying 2. And now this is a noteworthy moment. As you see, the system is no longer using any of the default reasoning. It is actually now entirely reasoning with the patterns it has learned from interaction. And the 19 receives as a reply 2 based on pattern considerations which have been learned. So that was the first system. Let's look at the second example. Again, I am asked to input a number. Let's say I shall say 6. This is what the sensor delivers to the system. The current situation here are not just 4 numbers, but actually 8 numbers. The 6 has been used to update the most recent history. Following the most recent history are the challenge-reply pairs. You're having here shown the most recent 4 challenges, the bottom one being the most recent challenge, and the replies belonging to them, the bottom being the most recently acquired reply. We see here my preset number in this design is not 32,000 but 0. If the system hasn't acquired any further knowledge, it will assume the value to be 0. That's just a design choice. What it has now learned is that a line of zeros shall be answered with a 6. You certainly notice that there have been other lines of zeros above here, and that they are answered with 0. But that doesn't matter, because they are older. The system will always prefer the most recent pattern. So if it sees anything like a line of zeros, it won't answer with a 0, it will answer with a 6. I shall now say 8. And this history apparently has been matched to a line of zeros. The reply of 6 has been issued because it matches this recognized pattern. And the new pattern has been learned, which is a line of zeros with a 6 in them to be answered with 8. It knows that because this is what I answered to this problem. If I now further interact with the system, the zeros will start to disappear more and more new patterns will be learned. So I'm telling it 78, it's telling 8. I'm now going to say 21, it's telling 78. I'm telling 63, it's telling 21. I'm telling 21, it's telling 63. Yeah, you see, it can actually learn such patterns of like 21, 63, 21, 63, and so on. Now I'm going to say 90. It tells 21. 11, it tells 90. 9, it tells 11. 8, it tells 9. Tell 10, it tells 8. Now look what stage it has reached. The history is now entirely composed of numbers from the interaction. No more default values are to be found in it. The challenges are now numbers from the interaction as well. There are no default values in them either, and their fitting replies are also learned from the interaction. Finally, we now have a system which is matching experienced patterns and giving us replies from experience. This is the most intelligent thing this setup is actually capable of. It is utterly elementary, but even my more complex designs, which are based on pattern matching, are not fundamentally different. I hope this somewhat clarifies the issue of how such a system can learn and in what way can it deliver a reply. Thank you very much for watching. I wish you much success and great fun at your artificial intelligence experiments, and in the description of this video you shall find where to look for these two programs. Have a great day, and thanks for watching once again. See you soon. Goodbye.